Hi friends, welcome back to Minute Rockets as we continue our build series on our KNSB sugar rocket motor. Today we're going to be machining the case and forward closure for our motor. So I'm going to start by looking at the liners. The black liner here is a liner from Loki Research, and the orange liner here is a liner from Always Ready Rocketry. And the purpose of the liner is to protect the aluminum tube from the hot gases that are burning inside of it. And so the liner is critical and needs to have a good fit on the tube. I always like to check the tubing when I get it, so I bring it here out of the package and then take a piece of liner and slide it in there, make sure it fits good, make sure that it first of all will go in and that it slides in nicely, that it doesn't wiggle, and just is a really nice slip fit in there. And so that was great. And then I always like to check the outside with a motor tube. So this is just a motor adapter from Lock that has a 38mm motor mount tube in it, and so that fit great as well. So our tubing is looking really good and we're ready to start our machining. So we'll start by printing out the drawings. Of course, it's always good to have a good drawing that you can work off of, so we'll take that drawing and we'll use it throughout the machining process. So we'll go down to the bandsaw. This is just a wood cutting bandsaw, but I used it to cut these the tube here. And it actually did remarkably well. I was surprised how well it did on this thin aluminum tubing. Cut right through it. This is 4x speed, but even at regular speed, it didn't take that long. I just sped it up to make the video a little bit shorter. So there's our piece of tubing there. I could just cut a little bit long. We'll cut it to final length on the lathe. So now we're gonna cut a piece for our forward closure. And this is out of solid 1.5 inch aluminum bar, and this was a little bit more tricky to cut on this bandsaw that I have. It took a long time. I had to use a lot of WD-40 to lubricate it and try to keep it cool, and I had to go really slow. So again, this is 4x, and even that I was probably pushing it faster than I should have. I should have been more patient and slow down a little bit, but you know, it got through it okay. And didn't cut quite straight, but we can fix that up on the lathe, and it was pretty hot at the end there. So now here out at the lathe, we're going to start with the piece that we cut for our forward closure, and we're actually going to make a piece to help with machining the case. You can see I'm using an aluminum soda can there to cushion the jaws on the piece of aluminum. Probably wasn't really necessary here because the aluminum was still rough, but I did. So we're just going to face that piece off, and we're going to cut a little shoulder in it that's going to be the right size to go on the end of our case, our tubing, so that when we machine the case we can use it in the tailstock to keep it straight. And so I had to do a few measurements and test fits to get this all to work, but in the end I got a really nice piece that's going to help us to keep the longer case straight in the lathe as we're machining it. And then just flipping that piece around, we'll just take a facing cut off of it to get it nice and straight on the other side, and then we'll bring in a center drill and drill a nice center hole that will fit in the tailstock of the lathe. And this piece we'll put on the other end of our case as we're machining it, the end away from the chuck, to hold the case straight. And you'll see that as we go through the thing. So it's a nice little piece, so we can use that on all the cases that we end up making in the future. So good piece. Now we'll just take the drawings for the case, and I like to just tape them to the lathe. That way they're always there. So I just tape them there to the headstock and just keep it there. So as we're going through all the machining, the drawings are real handy there. So now just chucking the tubing up into the lathe so we can start working on it to make our case. This is a little bit long out from the chuck to be working on it. You can see there's a little bit of wiggle there. Not ideal. It would be nice if I had a steady rest, but I don't. This case worked out okay. I think I'd have a little more trouble making one much longer. I think we were right about at the limit of what I would want to do. So just making a facing cut here, facing off the end of that case. This isn't cutting it to length yet. This is just working on this first end, and then when we flip it around, we'll cut it to length, and you'll see that. So once we get that facing cut, then putting our little piece we made into the end here and putting the tailstock on, that way it'll run nice and true. And then I just ran it for a little bit just to true it up on there, so it get that wiggle out of it. And I had to do this a few times as going through, if it started wiggling too much. Now I'll start cutting the groove in the end. So you can see I have the grooving tool there in the lathe. And what I do is bring that grooving tool right up to the end, and then I set my calipers for how far in I want it to be, and then I put that against the lathe and then run the lathe to the left until it bottoms out on the caliper. And that should give me the correct depth of cut for that, or the correct distance from the end of the case for that groove. And then again here, cutting the groove, just being real slow and careful this far away from the tailstock, or from the headstock, I should say. And even so, I had to take really light cuts, and it was singing pretty good. It was pretty, little bit of chatter going on, but I was able to get the groove cut, and it wasn't too bad. And I didn't have a really good way to measure the depth of the groove. So what I did is I just took a snap ring and put it in there periodically to check the fit. And I had measured the snap ring to see how thick it was. So I knew, this is about 60 thou thick, almost 70. And I needed a 40 thou groove. So based on that, I could get the groove pretty close, just from test fitting the clip in there. So you can see here that end is all cleaned up. It's got the groove in it, and things are looking pretty good. And then just one more look at putting the snap ring in there now that we're out of the lathe. Just a final test fit on that, clip it in there and make sure it holds securely and everything looks good. And it's looking pretty good, so I'm pretty happy with that groove right there. Now we're going to work on cutting the tube to the right length and then working on the other end. And getting it to the right length was a little bit tricky. My calipers weren't long enough. It's only a 6-inch caliper. So what I actually did is set it to the full 6 inches exactly, and then put a little scratch on the case at 6 inches, and then did the rest of the dimension there, and then started at that scratch and made a scratch at the other end. And so that tells me where I need to cut it, and then I just measured from the other end to see how much I needed to take off, and that actually worked out pretty well. So chucking it back up in the lathe, facing the other direction now so we can work on the other end, put our little cap on so we can true things up and start our cutoff. Okay, and what I did is I just took this cutoff tool and I just lined it up with that scratch I had made before I started the lathe. That way I knew that my cutoff tool was in the right spot, so I didn't have to use marking fluid or mark it or anything. I was a little bit worried about this cut, things getting jammed or anything, but whenever it punched through to the other side, things stayed together and left us with a nice clean cut, so I was pretty happy with that. So now on to cutting the groove for the other side. It's just the same thing we did before. Set the caliper to the depth we want, bring the tool right to the end of our tube, and then set the caliper on the tube and bring the tool in until the caliper bottoms out. Not sure what happened with the display on the caliper here. It didn't go all the way to 0, but I'm pretty confident that we hit the right spot with that groove. Just something up with the display there. So again, cutting that second groove. I actually found that if I sped the lathe way up, then that kept things a lot more stable on the end as I cut this groove. So at some point I realized that and sped the lathe way up, and you can see there's a lot less wiggle there on the end. Still made a lot of noise with the chatter going on, but it helped a lot just to speed things up. And again, doing the test fits with the clip, the snap ring there, to check my depth. Yeah, and it worked out pretty well. So once that groove was cut, put our end cap back in so we can true things up. And now I'm going to cut the external ring, the thrust ring that'll go on this end of the motor. And so for that, I set my caliper for how far I wanted it from the end, and then I tried to use a Sharpie sort of as a layout fluid. It worked okay, not as good as regular layout fluid, but it was good enough that I could see what I was doing, so that's good. So once we got the Sharpie on there, it's just a matter of taking our caliper and scratching it the right distance from the end, and then so there's the start of the groove, and then adding the width of this groove, then making another scratch, it lays out where that groove needs to be from the end of the tube. And then we'll just take our thinner cutoff tool here, or grooving tool, however you want to call it, and just cutting that groove here. This one, since it's on the outside, it was a little bit easier to cut. Obviously I could support the other end of the tube, and it was easier to check the depth from the outside. And so once that was cut, then just chamfered the corners, broke the corners a little bit so they weren't sharp, and make it look a little bit nicer. So that's what I'm doing here, just using this tool at a 45-degree angle to do that. All right, and so that's it. All the basic operations are done. We're going to do some cleanup to the case here, make it look nicer. But that, as far as the basic operations go, is done. It's got the 3 grooves in it, the 2 internal grooves and the 1 external groove. So just chucking it back up in the lathe to clean it up here a little bit. Just going to use a file to break those edges a little more, soften things up a little bit on the inside and then a little bit on the outside as well. Just so there's no sharp corners that are going to be uncomfortable handling the case. And a little bit on the end as well. And getting all the chips off with the compressed air there. And putting our end cap back on, and we're going to clean up the outside of this case here. So bringing the tailstock up to give us more support. And we're just going to clean it up here with the Scotch-Brite pad. And Scotch-Brite pads to me are almost magical. I learned this from YouTube, watching a YouTube channel called Precision Transmission. And they always talk about how Scotch-Brite's your friend. And man, it just works so well. You can see how shiny that got just from a few seconds of Scotch-Brite. Flipping it over, this is the other end. I'm just going to take our Scotch-Brite pad and, firm pressure with the lathe running, and that just cleans it right up. Makes it really nice and shiny, that aluminum. And takes off, our layout fluid and any scratches or imperfections that were on the case. Really makes things look nice. So there we have it. Our case is finished. It's all cleaned up. Pop it out of the lathe there and take a look. So you can see there the nice shiny finish we got on there. I'm not planning to anodize these or anything. I don't have a way to do that. So we're just going to keep this nice aluminum finish, and just ending with some photos. There you can see I've got the thrust ring in there, and just some close-up photos of the ends with the grooves. Really happy with the way the case turned out. And so it'll be on to the forward closure next. And so with the forward closure, the same as the case, I'm going to tape the drawings to the headstock of the lathe. That way I have them there handy throughout all the operations that I'm going to be doing here with the forward closure. And we'll take our little chunk of aluminum, the piece that we had left over, and chuck it up in there. And you can see again that cut wasn't too straight on the bandsaw, but that's okay. That's what the lathe's for. So we'll start by facing off that end, get things nice and straight and square, so we can do that. And I've made a few of these forward closures, and it's always kind of a struggle to hold them in the lathe without marring the aluminum. The aluminum is pretty soft, and the chuck jaws are hardened steel. And there's not a lot of surface area once you start cutting on these things to hold them. So one of the things I did this time was I faced off this end and then threaded it first, and I'm going to hold it by those threads, and that worked really well. So you can see there I got the end faced off, and then just starting a pilot hole, and we're going to put a 1/4-20 thread here in the end, and this will be the outside end, and where we'll put our forged eye bolt, where we can attach our motor to the recovery hardware inside the rocket. So in woodworking, it's pretty common to put a piece of tape on your drill bit to mark your depth before you start drilling. And so that's what I did here. It didn't actually work out too well here with the metal for a couple of reasons. So those chips that come out, they very quickly started to push on that tape and moved it out of the way. And especially that in combination with the WD-40 that I sprayed in for lubrication, that tape did not stay where it was supposed to stay. So that's okay. The tailstock is graduated, so I could see from it how deep I had gone approximately, and then I can also check with my calipers. And it looks like I'm actually drilling a lot deeper than what I had marked, but it's okay. I drilled to the right depth. I actually did. Actually decided I wanted a 1/2 inch deep hole so I could get better grip with especially holding it in the lathe. So you can see there we almost a 1/2 inch. The depth of this hole is really not critical at all. It's just for screwing our eye bolt into, and so about a 1/2 inch is what I ended up going with. I think I had like 3/8 of an inch on the drawing, but ended up going right at a full 1/2 inch. The only thing that's real critical here is that you don't obviously drill all the way through your closure, because you don't want that to be an open hole into your motor. That would be bad. So just, again, periodically checking the fit here. Just over 1/2 inch there, so I was real happy with that. All right, and then we'll just get a 1/4-20 tap is what I used here. Chuck that up in the drill, and then just hand tapping there with the drill. This was a little bit not ideal. Would have been better to have a tap handle with the follower probably, but I was able to get the job done. Took a few tries and some oil grease to do it this way. Turning the whole lathe by hand was not ideal, but it worked. So if it works, right? So this is a taper tap, and then I went back in with a bottoming tap to get it tapped all the way down to the bottom. Again, 1/4-20 is the size here, and that's the size of the eye bolts that we ordered. That'll go right here in this hole. And that held it just fine for the rest of the operations here on the other end. So again, using some Sharpie for some layout fluid, layout dye. I worked pretty well on this, actually, better than it did on the case. And then just taking our caliper, and we'll just put in some scratches at the different places. Because of where the chuck is, I can't do the scratches really while it's running, but right now I'm just trying to mark the length. And that didn't work great, but because I wasn't able to index off the inside. So here we're just facing it off and getting it to the right length and checking with the calipers as we go. Just stopping the lathe and checking with the calipers every once in a while and taking little cuts until we get in and get the size that we need. And here you can see I'm finally just taking the caliper and putting my tool right at the right length, just using the caliper to put the tool in the right spot, and then just took a little cut there so I could see how far I needed to go in, and then I still had to go out a little bit and take some smaller cuts. My lathe isn't super powerful, so I have to take smaller cuts than what I might like. Final pass here, and check in for our final length, and everything looks good. That's the length we wanted, so we're ready to move on. So now we're just going to clean up the outside and turn it down to the final diameter to fit inside our motor tube. And you can see here how holding it by the threads on the end really give us access to that full surface, and we can do all our operations, and works really well. I did have to move it out a little bit from the chuck. I had it right up against the front of the chuck, and I had to move it out a little bit so I could get access to the full edge of the piece with the tool. But since I did that before we finished turning it down all the way, we shouldn't lose any concentricity because of that, so no problem. And we'll just get it turned down to the correct diameter, checking as we go until we make sure it fits and that it's the diameter that we have on the drawing. So now that our closure is the correct diameter and it's the correct width and faced off, then we can start laying out the position of the other cuts we're going to make. So in the front we'll have a shoulder that will accept the liner. That's what I'm marking out right there. And then we're going to have an O-ring groove, and so I'll put 2 lines there for the start and end of that groove. And so that's what we need to cut next. So we'll start with the shoulder on the liner. And this shoulder on the closer for the liner is probably the most critical part as far as being the right dimensions, especially as far as diameter. And so we want the shoulder to have a nice fit on here. We want it to be snug but not tight, because this helps to seal the hot gases that are in the engine. So we want the liner to fit on here real nice. So we'll take our time and really get a good fit there, get the correct diameter, and do some test fits with the liner to make sure we get that good to go. So last but certainly not least is the groove for the O-ring. So we'll cut that groove last, and this O-ring is really important as well. It seals the case on the forward end to keep the exhaust gases from coming out. So the O-ring sits in this groove, and it sits against the inside of the case on the forward end, and the forward closure is contained by that front snap ring, and this O-ring is what creates that seal. So it's pretty important that the diameter be right and that it be about the right width. So again, lots of checks for the diameter and just sneaking up on it to get the right width and the right diameter. Then just cleaning things up, getting things ready. And then again, just breaking the edges with a file so we don't have sharp corners on everything. So I'll take the file and break all the edges just to make things cleaner and safer, I guess, to handle. Then just using, this is a jar opener pad to get it unscrewed. It gets pretty tight there, making all those cuts. So just unscrew it here, and that's it for the forward closure. It's pretty much done. Get some close-up shots of it there. You can see the threaded hole there. Looks really good. The O-ring groove, and then the shoulder for the liner there. And then I will screw our eye bolt into that threaded hole there, and then we'll be ready to put this in the motor. So I hope you enjoyed that video. That's the machining of the case and the liner. Here's some pictures of the results. I think they turned out really well. I'm really happy with them. And you can see some teaser pictures there of the nozzle as well. So the next video will be machining the nozzle, and that'll be a great video. This one was just too long already, so I didn't want to make them all one super long video. And the nozzle, there's enough there, I think, to have its own video. So be sure to like and subscribe, and that way when I get the video of the nozzle done, you'll be notified, and you'll be notified of all my future videos. So thanks for watching.